Hello children, hope you are all doing good. Today I welcome you all for this mathematics class of 10th standard on the topic similar triangles, which is the second part. I hope you all have gone through the first part of similar triangles explained by V.S. Madam. Today we'll try to understand what is similar triangles through an example, and then we'll move on to basic proportionality theorem. Let us try to understand what is similarity. Two figures are said to be similar if and only if they have same shape but not necessarily the same size. That is similarity. Now we shall look into similar triangles. Two triangles are said to be similar if their corresponding angles are equal, or the corresponding sides must be in proportion. That is the condition for two triangles to be similar. You can observe here there are two triangles marked with angles as x, y and z, and the sides as A, B and C in one triangle. In the second triangle, you can observe the angles marked again as x, y and z, but the sides are taken as P, Q and R. Corresponding sides will be in the ratio, that is, the corresponding sides opposite to angle x in the two triangles are A by P. Similarly, the corresponding sides opposite to angle y in the two triangles are B by Q, and the remaining angle is Z. The corresponding sides opposite to angle Z in the two triangles are C by R. That is how we identify the corresponding sides. Now let us try to identify corresponding angles and corresponding sides in two triangles using an activity. Let us try to identify the corresponding angles and corresponding sides in these two triangles here. We have triangle ABC and triangle DEF. Angle CAB is equal to angle FDE. These angles are marked with single arc. You can observe that angle CAB will be equal to angle FDE. That is the angles marked with single arc in these two given triangles. Then angles marked with double arc are angle ABC with angle DEF. These are the angles marked with double arc, and then the angles marked with triple arc are angle BCA is equal to angle EFD. These are considered as the corresponding angles which are equal in these two triangles. Now let us try to identify the corresponding sides. Opposite to the third or triple mark angles are AB and DE. That is the first pair of corresponding sides that we are considering in these two triangles. AB and DE are the corresponding sides as they are opposite to angles marked with 3 arcs. Then the corresponding sides opposite to the angles marked with 1 arc are BC and EF are the next pair of corresponding sides. Then the remaining third pair of corresponding sides are the ones which are opposite to the double arc angles, that is AC and DF. That is the remaining third pair of corresponding sides in these two triangles given over here. That is the method of identifying the corresponding angles and corresponding sides. You can practice such triangles with identification of sides and angles with your own examples. Let us move on with Thales theorem or basic proportionality theorem. This was proposed by a Greek mathematician by name Thales. You can see the image of Thales. He was considered as one of the 7 sages of Greece. He is also the first philosopher in Greece regarded by Aristotle. He applied deductive reasoning in geometry. In the road there are street lights. By considering this situation, let's see what we can come up with. Consider that there are 2 light poles on both the sides of the road, and let's draw 2 triangles by joining these 4 points. So by looking at this diagram, what is common between these 2 triangles? They have common base and height. These 2 triangles have common base and height. This boundary of the road form parallel lines. The distance between these 2 parallel lines is always equidistant. Area of the triangle is given by the formula half into base into height. Since base and height are equal in both the triangles, its area will definitely be equal. So what is the conclusion from this property? Triangles drawn between 2 parallel lines with same base have equal areas. Now consider another situation where we have 1 light pole on one side and 3 light poles on the other side. By joining this we get 2 triangles. What is common between these 2 triangles? If we notice, we know that height is common but base is different for both the triangles. We have split a triangle into 2 by drawing a line between them. Here we don't need 2 parallel lines to show that these triangles have equal height. So what is the conclusion from this activity? We can conclude that if we draw 2 triangles by splitting a single triangle, its height will be equal, and when we find the area of these 2 triangles, they are not equal, but the ratio of their areas will be equal to the ratio of their bases, because half and height will get cancelled as it is constant. That is the second property. The third property is, if a straight line is drawn parallel to a side of a triangle, then it divides the other 2 sides proportionally. DE is the line parallel and the proportional sides are AD by DB is equal to AE by EC. We can prove this statement by using two properties that we have learned earlier. This can be done in 3 steps. If we see the left part, we have AD by DB, which is to be proved in the first step. Consider two triangles involving these sides. Triangle ADE, we get line joining BE to get the triangle DBE, so that it will become a triangle with the side DB. Area of triangle is half into base into height. Since AD and DB are needed for the proof, let us take them as base for the respective triangles. It is taken from a larger triangle AEP. By using the second property, we can say that height is same. So, ratio of area of triangle ADE by area of triangle BDE is equal to half into AD into height and half into BD into height. Since half and height are common, we can cancel it and we get the ratio of area of triangle ADE by BDE as AD by DB, which is the proof for the first part of this theorem. In the second step, there are two sides AE and AC. So join line segment DC. We can write it as ratio of area of triangle ADE upon ratio of area of triangle CDE as half into base into height. Half and height are constants here, so they get cancelled and we get AE by CE as the ratio for these two triangles. Let us move on or take it as equation 1 and 2. Now the final step, AD by DB is equal to AE by CE. To prove them as equal, we need to consider the left hand side of equation 1, that is area of triangle ADE upon area of triangle BDE. Similarly, the left hand side of second equation is ADE upon area of triangle CDE. To prove RHS as equal, we have a common triangle ADE. We must prove that BDE and triangle CDE to be equal. Let us focus on triangle BDE and triangle CDE. The area of these two triangles are equal from the first property that we have already learnt, as DE is parallel to BC and height will also be equal in these two triangles as they are on the common base DE. Therefore, area of triangle ADE will be equal to area of triangle CDE, that is from the first property that we have learnt. From equations 1, 2 and 3, we can now say that area of triangle ADE is equal to area of triangle CDE, which means the RHS, that is AD by DB, will be equal to AE by EC. This completes the proof of basic proportionality theorem, which states that if a straight line is drawn parallel to one side of a triangle, then it divides the other two sides proportionally. This is basic proportionality theorem or the Thales theorem. That is the third property that we have learned in today's class. Very important theorem to be practiced for your final examination. Now let us try to understand the converse statement of basic proportionality theorem or the Thales theorem. Only the statement is important here. Proof is not a part of your syllabus. Converse of basic proportionality theorem states that if a line divides any two sides of a triangle in the same ratio, then the line is said to be parallel to the third side. You need to write this statement, read and practice it. Proof is not required for this. In this triangle ABC here, if AD by DB is equal to AE by EC, then DE will be parallel to BC. That is the converse of basic proportionality theorem. Now let us look into the numericals based on basic proportionality theorem and also the converse theorem. In the triangle ABC here, DE is parallel to BC. AD by DB ratio is given as 3 by 4 and AC line segment measurement is 14 centimeters. By using this given data, we need to find the length of AE. Now look at the solution of this. In triangle ABC, since DE is parallel to BC, by applying Thales theorem, we can write the sides which are proportional. That is, AD by DB is equal to AE by EC. You can observe in the second step here, EC is written as AC minus AE because the measure of AC is given here, so we are converting EC as AC minus AE. Now by substituting the given values, we get the third step, which is 3 by 4 is equal to AE by 14 minus AE. When you cross multiply this, we get 3 times of 14 minus AE is equal to 4 AE. When you multiply 3 with both the terms, 3 times of 14 will be 42 minus 3 times of AE, which will be equal to 4 AE. When you transfer this 3 AE to the left side, that becomes 4 AE plus 3 AE. That gives us 7 AE, which is equal to 42. If you simplify this, we get AE as 42 by 7. 42 when you divide by 7, we get 6 times. Therefore, length of AE is 6 centimeters. I hope you have made note of this problem in a notebook neatly so that you can practice it again and try to understand the steps involved in solving this problem. This is a numerical based on basic proportionality theorem. Now let us move on to a problem related to converse of basic proportionality theorem. In this numerical here, you can observe triangle ABC is given with AD as 18 centimeters, DC as 6, AE as 24 and EB as 8 centimeters. We have to verify whether DE is parallel to CB or not. Since the ratios of the corresponding sides must be proportional, we will verify that here. That is 6 by 18 is equal to 8 by 24. We get this by taking AC by AD, which is equal to AB by AE. When you simplify this, we get the ratio as 1:3. Since all the three ratios, that is 6 by 18, 8 by 24 and 1 by 3 are equal, therefore we can come to the conclusion that DE is parallel to CB. This is based on the converse statement of basic proportionality theorem. Now it's time for homework based on these two theorems that we have learnt in today's session. There are two problems given in today's homework. In the first triangle, you can observe that ABC is taken where DE is parallel to BC. AD is given as 1.5 centimeters, DB is 3 centimeters. AE measure is given as 1 centimeter, and we need to find the length of EC in the first question. And in the second one, they have given that DB is 7.2 centimeters, AE is 1.8 centimeters, EC is 5.4 centimeters. By using BPT, we need to find the length of the side AD. Hope you can solve these two simple problems. Thank you for listening to this class.